Hi everyone, myself P. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today our topic is use of partial fractions to find inverse Laplace transform. Okay, use of partial fractions to find inverse Laplace transform. Previously, what we discussed in the previous classes, we discussed inverse Laplace transform derivatives and integrals. Function is multiplied with s and the function is divided by s, and the first shifting theorem, second shifting theorem, and scaling property. All we discussed in the previous classes. Now the topic is use of partial fractions to find inverse Laplace transform. Already we know that partial fractions in the previous years. Okay, now I discussed that partial fractions related to the inverse Laplace transform. Okay, for the first question, find Laplace inverse of 2s plus 1 by s plus 2 whole square into s minus 1 whole square. Once you observe here the given question, is there any possibility to write direct answer for the first question? Here what is the question? Laplace inverse of 2s plus 1 by s plus 2 whole square into s minus 1 whole square. Is there any possibility to write the previous properties on this question? There is no possibility. Previous properties means what? First shifting theorem, second shifting theorem, scaling property, and next derivative part integral. Directly, is there any one is okay? If you are using the property on this question directly, we got any answer for that? No. First we have to separate the 2s plus 1 by s plus 2 whole square into s minus 1 whole square. First we have to separate the given function. Okay, then we got the answer for that. How to separate the denominator part? First we have to separate the denominator part here. After that we got the answer for the given question by using Laplace transform. But how to separate the denominator part? By using partial fractions only. Here we got, okay, we have to divide the denominator part. Okay, then here the given question, what is f of s? That is 2s plus 1 by s plus 2 whole square into s minus 1 whole square. Once you observe here where we are using partial fractions, where we are using partial fractions, where we are using partial fractions, if the denominator, if the numerator power is less than of the denominator power. Okay, for that case only we are using the partial fraction. Here also you observe the numerator, here s power as 1 and here 2. That means 1 less than 2. Okay, for that case I'm using partial fractions. How to use that partial fractions? Here I'll write that as, okay, first I'm taking the function as here a by s plus 2, a by s plus 2 plus, okay, here whatever the next term, I'll write here s plus 2 whole square as s plus 2s plus 1 by s plus 2 into s plus 2 whole square, that is s plus 2 whole square, and s minus 1 and s minus 1 whole square form. That's why I'm simply first I'm writing the first power of s plus 2, that is a by s plus 2 plus b by s plus 2 whole square plus, and whatever the next part here, c, okay, s minus 1 whole square. Now I'll write that as c by s minus 1 plus one more d by s minus 1 whole square. Okay, here what are the unknowns? By using the partial fractions, a, b, c, d are the unknowns. Now I can calculate that values. Once you observe by using the partial fractions, here the denominators are separated. That is a by s plus 2 form plus b by s plus 2 whole square form plus c by s minus 1 form plus d by s minus 1 whole square form. Okay, by using the partial fractions only, here we got the answer for the first question. That is, here this is equal to what? Here what is the numerator part? That is 2s plus 1 by 2s plus 1 by s plus 2 whole square into s minus 1 whole square. Okay, now simply I'm writing the 2s plus 1 by s plus 2 whole square into s minus 1 whole square as a by s plus 2 plus b by s plus 2 whole square plus c by s minus 1 plus d by s minus 1 whole square. Now I am finding a, b, c, d unknown values. Okay, how you got a, b, c, d values? Okay, here I am taking LCM of the RHS part, that is a into what is a LCM here? S plus 2 whole square into s minus 1 whole square. Okay, there e into s plus 2 into here b means here s minus 1 whole square plus c into what? That is c into s minus 1 into here s plus 2 whole square plus d into here d into what? S plus 2 whole square. Okay, that is equal to 2s plus 1 by s plus 2 whole square into s minus 1 whole square. Here both sides denominators cancelled. Both sides denominator cancel. After that we got 2s plus 1 is equal to a into s plus 2 into s minus 1 whole square plus b into, here I am missing b, here what is b? Here b as s minus 1 whole square. I am writing in the last term. Here a into s plus 2 into s minus 1 whole square plus c into s minus 1 into s plus 2 whole square plus d into s plus 2 whole square plus b into, okay, here I am writing b into s minus 1 whole square. For that denominator cancel, we got that as 2s plus 1 is equal to a into s plus 2 into s minus 1 whole square plus b into s minus 1 whole square plus c into s minus 1 into s plus 2 whole square plus d into s plus 2 whole square. For that, now I am finding unknown values of a, b, c, d. Okay, from that, what is the case here? That is 2s plus 1 is equal to 2s plus 1 is equal to, once again I'll write this step here, a into s plus 2 into s minus 1 whole square plus b into s minus 1 whole square plus c into s minus 1 into s plus 2 whole square plus d into s plus 2 whole square. Once I'll cross check that, 2s plus 1 is equal to a into s plus 2 into s minus 1 whole square plus b into s minus 1 whole square plus c into s minus 1 into s plus 2 whole square plus d into s plus 2 whole square plus d into s plus 2 whole square. Okay, from that, first for that equation, first I'll find out, okay, put s is equal to, for example I'm substituting here s is equal to 1. What will happen? What we got from that? If you are substituting s is equal to 1, for that case, okay, I'm substituting in the above equation, that is 2 into 1 plus 1 is equal to a into s plus 2 into 1 minus 1 whole square plus b into 1 minus 1 whole square plus c into 1 minus 1 into 1 plus 2 whole square plus d into 1 plus 2 whole square. Once you observe, after substituting s is equal to 1 for that a part, okay, that is 1 minus 1 means that as a of 0 plus b of, what is 1 minus 1 whole square means, that is also 0 plus c into 1 minus 1 into 1 plus 2, that is anyway that is 0 plus d into, what is d here? Once you observe, 1 plus 2 as 3 square. Okay, therefore from that if you are substituting s is equal to 1, that is 2 plus 1 as 3. Okay, that is 2 plus 1 as 3. From that 3 is equal to d of 9. D of 9. Therefore, D is equal to what? 3 by 9. That is equal to 1 by 3. 3 is 9. Therefore, D is equal to how much? 1 by 3. If you are substituting S is equal to 1, from that case we got D is equal to 1 by 3. Okay, for the same equation, okay, here we got only one unknown value, that is D as 1 by 3. If you are substituting S is equal to 1. What about the remaining parts? A, B, C values. Okay, now I am substituting S is equal to minus 2. Okay, that is we got one unknown value, that is D is equal to 1 by 3. For the same equation, now I am substituting S is equal to minus 2. Why I am substituting only S is equal to minus 2? Why? Because if you are substituting minus 2 only, A 0 and C 0 and D 0. If A, C, D are 0, directly we got B value. Okay, now. Okay, if S is equal to minus 2. If S is equal to minus 2, for that case, now I'm substituting that value. How we got that value? I'm substituting here, my 2 minus 2 plus 1 is equal to A into 2 minus 2 plus 2 into minus 2 minus 1 whole square plus B into minus 2 minus 1 whole square plus C into minus 2 minus 1 minus 2 plus 2 whole square plus D into minus 2 plus 2 whole square. From that here LHS part 2 into minus 2 minus 4 plus 1 is equal to here minus 2 plus 2, that is A as 0 plus B into minus 2 minus 1 is how much? That is minus 3 whole square plus C into, what about the C part here? There also minus 2 plus 2, that means this as 0 plus D into minus 2 plus 2, that is 0. Therefore, here minus 4 plus 1 is how much? Minus 3 is equal to B of A0, C0, D0. From that case, we got only B value, that is here B of minus 3 square means that is 9. Minus 3 is equal to B of 9. Therefore, B is equal to how much? Minus 3 by 9, that is minus 1 by 3. Therefore, if we are substituting S is equal to minus 2, we got B is equal to minus 1 by 3. If you are substituting S is equal to 1, for that case we got D is equal to 1 by 3. Okay. Now we got the unknown values of D and B. Now what are the unknown values? Here A and C. Now we have to find out A and C values. Okay, now I am finding unknown values of A and C. There is no possibility to directly substitute S is equal to 1 and S is equal to minus 2. We are substituting S is equal to 1 and S is equal to minus 2. For that case, we got D value and B value. And what about the next possibility to find A and C? Is there any possibility to take A and C values from here? No possibility. Okay, for that case here, now I'm multiplying total equation and comparing the coefficients on both sides. Okay, here A into S plus 2 into S minus 1 whole square. That means what? A minus B whole square, that is S square plus 1 minus 2S plus B into S minus 1 whole square, that means S square plus 1 minus 2S plus C into S minus 1 into S square plus 4 plus 4S plus D into S square plus 4 plus 4S. Okay, in LHS side only 2S plus 1. Okay, from that comparing, maybe here I am comparing the coefficients of S cube. Okay, how I am comparing the coefficients here? First I'll multiply here A into, okay, S into S square means S cube plus, okay, yes, minus 2S square. Next, plus 2S square plus 2 minus 4S. Okay, this is A part. From that B part plus B into S square minus 2S plus 1 plus C part, here I am writing C into, here S into S square means S cube plus 4S S cube plus 4S plus 4S square plus 4S square, and next minus S square, next minus 4 minus 4S. This is C part after multiplying with S minus 1 plus D into, what is D here? S square plus 4S plus 4. And the LHS side here 2S plus 1. Here the LHS side 2S plus 1. Now I am comparing the coefficients of S cube. Here what are the comparing the coefficients of S cube? Where here? That is A of S cube. Okay, here comparing coefficients of S cube. Okay, if you are comparing the coefficients of S cube, is there any chance to get the answer for either A and C? Okay, once I'll observe here. A of S cube, that means A of S cube, here A, S cube coefficient as A. And the next from B, there is no S cube, neglect it. And from that C, what about the S cube coefficient? C. That is A plus C. Okay, if you are comparing the coefficients of S cube on both sides, for the LHS side, there is no S cube term. That means that value is equal to how much? 0. Okay, that is A plus C is equal to 0. We are comparing the coefficients of S cube, we got A plus C is equal to 0. We got one equation only, not we got the unknown value of A and C. Got one equation form. Okay, and next I'm comparing the S square coefficients also. What are the S square coefficients here? S square coefficients from that A part, here minus 2S square plus 2S square cancel. There is no S square coefficient on A. From that B, S square coefficient as 1. That means I'll write here comparing coefficients of S square. Okay, that is in that A there is no S square, that is 0, plus B means in that B S square is there, that's why I'll write B. And what about this S in S square in C? Here in S square in C, 4S square minus S square, that is 3S square. That means here we got minus 3C, right? Okay, here we got B plus minus 3C plus D. Okay, from the D, what about the coefficient of S square? 1. That means 1 into D as D. Okay, once you observe here, that is C into S cube plus 4S plus 4S, next minus S square minus 4 minus 4S. Okay, here we got B plus 3C plus D is equal to, what about the LHS side? LHS side, that has 0. Okay, there is no S square coefficient. Okay, from that here, if you are comparing the coefficient of S square, we got B minus 3C plus D. From that, what we know here, D value we know, and remaining B value also we know. Okay, now substitute here. What is B value? Minus 1 by 3 minus 3 into C plus what is D value? Plus 1 by 3. Here B plus 3C, no, here B plus D plus 3C is equal to 0. Equation is B plus 3C plus D is equal to 0. From that, substitute B and D values. Okay, after substituting here, 1 by 3 minus 1 by 3 cancel. Therefore, C is equal to 0. Therefore, C is equal to 0. Substitute that C in the above equation. What is the above equation? A plus C. Substitute here. Therefore, A is also 0. Okay, substitute there. A is 0 and here C is 0. From that concept, now we got A, B, C, D unknown values. What are the unknown values of that? A is equal to 0 and B is minus 1 by 3 and C is equal to 0 and D is equal to 1 by 3. Now substitute that all values and after that apply Laplace inverse on the above function. Therefore, here a is equal to 0 and b is equal to minus 1 by 3 and c is 0 and d is equal to 1 by 3. Okay, therefore the given question has 2s plus 1 by, here plus 1 by s plus 2 whole square into s minus 1 whole square is equal to what? That is a by, okay, substitute in the above equation, that is 0 by s minus, once I'll check that, a by s plus 2, a by s plus 2 plus b is minus 1 by 3 by s plus 2 whole square plus c means 0 by s minus 1 plus d means 1 by 3 by s minus 1 whole square. Therefore, from that here a and c is 0, that is minus 1 by 3 into s plus 2 whole square plus 1 by 3 into s minus 1 whole square. Minus 1 by 3 into s plus 2 whole square plus 1 by 3 into s minus 1 whole square. This is equal to what? This is equal to 2s plus 1 by s plus 2 whole square into s minus 1 whole square. Now apply, once you see after using the partial fractions easily here denominator will separate, that is how it will separate, minus 1 by 3 into s plus 2 whole square form plus 1 by 3 into s minus 1 whole square form. Now both sides apply Laplace inverse. Therefore Laplace inverse of 2s plus 1 by s plus 2 whole square into s minus 1 whole square is equal to what? Laplace inverse of minus 1 by 3 into s plus 2 whole square plus 1 by 3 into 1 by s minus 1 whole square. From that, what is the formula of that? Here, I'll take minus outside, 1 by 3 is also outside, and the remaining as Laplace inverse of 1 by s plus 2 whole square plus 1 by 3 into Laplace inverse of 1 by s minus 1 whole square. 1 by s plus 2 whole square plus 1 by 3 into Laplace inverse of 1 by s minus 1 whole square. Okay, next step. Next continuation here, that is therefore minus 1 by 3 into Laplace inverse of 1 by s plus 2 whole square plus 1 by 3 into Laplace inverse of 1 by s minus 1 whole square. That is equal to, here I am applying the first shifting theorem on the first part of the answer here, 1 by s plus 2 whole square formula, that is here, okay, that is t, directly I am writing here, that is 1 minus 1 by 3 into t into e power minus 2t. By using first shifting theorem and Laplace inverse of 1 by s square, that is t into e power minus 2t plus 1 by 3 into, again here the same, here t into 1 by s minus a, that is e power minus t. Okay, therefore here answer 1 by 3 into t into e power minus t minus e power, here minus also there, that is e power minus 2t. 1 by 3 into t into e power minus t, sorry, t is also common, here t by 3 into e power minus e power plus t. Why? Because here 1 by s minus a means that is e power t form, that is e power t minus e power minus t. Therefore, for the final answer for the question, Laplace inverse of 2s plus 1 by s plus 2 whole square into s minus 1 whole square is equal to what? T by 3 into e power t minus e power minus 2t. Okay, this is the first question answer. Okay, next question. Find Laplace inverse of 4s plus 5 by s minus 1 whole square into s plus 2. Once you observe, is there any possibility to direct answer for the 4s plus 5 by s minus 1 whole square into s plus 2? There is no possibility. For that case, apply same as previous question. Here, apply first partial fractions. That is, first, what is the function from the question? 4s plus 5 by s minus 1 whole square into s plus 2. That is 4s plus 5 by s minus 1 whole square into s plus 2 is equal to, how to separate the denominator here? Once you observe, numerator power as less than of the denominator. For that case, I am using partial fractions, that is a by s minus 1 plus b by s minus 1 whole square plus c by s plus 2. A by s minus 1 whole square plus b by s minus 2 whole square plus c by s plus 2 whole square. Okay, now, okay, I'm taking the LCM on both sides here. That is, here the LCM for the RHS part here, a into s minus, okay, here the LCM is s minus 1 whole square into s plus 2. For that, a into s minus 1 plus b into s plus 2 plus c into what? Here s minus 1 whole square. That is equal to here 4s plus 5 by s minus 1 whole square into s plus 2. 4s plus 5 by s minus 1 whole square into s plus 2. Both sides denominator cancelled. Therefore, that is 4s plus 5 is equal to a into s minus 1 plus b into s plus 2 plus c into s minus 1 whole square. Here, what are the unknowns? A, B, C. Now, we have to find the unknown values of A, B, C, and after that apply Laplace inverse. Okay. Here, how we got A, B, C unknown values? Once you observe, if you are substituting S is equal to 1. Okay, here, if S is equal to 1, okay, substituting the above equation, that is 4 into 1 plus 5. 4 into 1 plus 5 is equal to A into 1 minus 1 plus b into 1 plus 2 plus c into 1 minus 1 whole square. Okay, from that, if s is equal to 1 means here, let's just side 4 plus 5 as a 9, a of 0 plus a of 0 plus b of 2 plus 1 as 3 plus c is 0. A of 0, and that means if you are substituting s is equal to 1, here a is 0 and c is 0. Therefore, 9 is equal to b of 3. From that, b is equal to how much? B is equal to 3 by 9, that is 1 by 3. If you are substituting s is equal to 1, from that case we got b is equal to 3. Okay, b is equal to 3. Next, how we got the remaining values of a and c? Okay, by substituting s is equal to 1 only, we got the first value of b, but how we are finding the remaining unknown values a and c? Okay, here is there any possibility to write s is equal to minus 2 and like? No, there is no possibility. For that case, comparing the coefficients on both sides, either s square or s cube or s. Okay, then next case. Okay, next here. First I'll multiply the equation here. A of s minus a plus b of s plus b of 2 plus c of s minus 1 whole square. That means what here? S square minus 1 s square plus 1 square minus 2s. S square plus 1 square minus 2s is equal to here LHS side 4s plus 5. 4s plus 5 is equal to a of s minus a plus b of s plus b of 2 plus c of s square plus 1 square minus 2s. Once you observe here, if you are comparing the S coefficients on both sides, here in the above equation, what is the coefficient of S? A. Okay, here comparing coefficients of S. Comparing the coefficients of S in the above equation, that is A, A, and the next one B of S. S coefficient is what? B. And from the last here C coefficient is what? C of S square plus C of 1 square minus 2 into S. That means minus 2 into C. That is A plus B minus 2C is equal to here. LHS side S coefficient is how much? 4. Therefore, if you are comparing the coefficients of S, we got the equation from as 4 is equal to A plus B minus 2C. That is A plus B minus 2C is equal to 4. Let us take that as the first equation. Okay, let us take that as the first equation here. Okay, from the first equation here already we know that B has 3. Now substitute here. 4 is equal to A plus 3 minus 2C. A plus 3 minus 2C. From that, A minus 2C is equal to what? 4 minus 3. That is 1. Okay. Let us assume that as the first equation. That is A minus 2C is equal to 1. A minus 2C is equal to 1. Okay. I'll write that step here. That is A minus 2 is equal to 1. Now I am comparing both sides. S square coefficients. Now I am comparing both sides. S square coefficients. Here, what are the S square coefficients from the equation? Okay, I'll write clearly here. A of S minus A, BS plus 2B plus CS square minus C minus 2SC is equal to 4S plus 5. Okay, 4S plus 5 is equal to AS minus A plus BS plus 2B plus CS square minus C minus 2CS. Okay, from that comparing both sides, S square coefficients. Comparing S square coefficients. Okay, once you observe LHS side, is there any coefficient of S square? No, that is 0. That is equal to 0. From here, what are the S square coefficients here? Only C. Okay, S square coefficient, that is for some comparing the coefficient of S square only here A, C only, that is C is equal to C only here A into S minus 1 plus B into S plus 2 plus C into S minus 1 whole square. I'm sorry, here here A into S minus 1 into S plus 2 is also there. Okay, A into S minus 1 into S plus 2 is also there. In the previous step, directly S is 1 means directly A is 0. That's why here there is no mistake. But here A into S minus 1 into S plus 2. A into S minus 1 into S plus 2 plus B into S plus 2 plus C into S minus 1 whole square by S minus 1 whole square into S plus 2. Okay, sorry, this is wrong. Okay, next continuation. Okay, 4S plus 5 is equal to, now I am multiplying A into S minus 1 into S plus, that is A into S square plus 2S minus S, A into S square plus 2S minus S minus 2 plus B into S plus 2B plus C into S square plus 1 minus 2S In the above step also I wrote mistakenly, that is a into s minus 1 into s plus 2 ma. That is 4s plus y is equal to a into, that is a into s square plus 2s minus s minus 2 plus b of s plus 2b plus c of s square plus c minus 2cs is equal to 4s plus 5. Okay, now compare the coefficients of s square here. Comparing coefficients of s square. Coefficients of s square. Once you see the LHS that there is no s square coefficients, that means that is 0. But from the RHS side, a s square coefficient as a. And b there is no s square, that is 0. And what about the c here, s square coefficient, from that c s square coefficient as c. Therefore here a plus c is equal to 0. A plus c is equal to 0. If you are comparing the s coefficients on both sides, we got a minus 2c is equal to 1. Let us take that as the first equation. If we are comparing the coefficients of s square, from that we got a plus c is equal to 0. Okay, that is, take that as the second equation. Okay, next. Okay, now solve 1 and 2. Solve 1 and 2. Solve 1 and 2. That is, a minus 2c is equal to 1, a plus c is equal to 1. Okay, from that here I am taking minus minus and minus, a minus a cancel, and minus 3c. A minus 2c is equal to minus, okay, here minus 3c is equal to here a plus c. Okay. That is minus 3 is equal to 1, c is equal to minus 1 by 3. If you are solving first and second equation, sorry I am writing here first one, that is a plus c as 0, that is a minus 2c is equal to 1 and a plus c is equal to 0. From that we got c is equal to minus 1 by 3. Now substitute c value in any equation of 1 and 2. Okay, I am substituting c is equal to minus 1 by 3 in the first equation. Okay, substitute c is equal to minus 1 by 3 in the first equation. That is, a minus 2 into minus 1 by 3 is equal to 1. That is, a plus 2 by 3 is equal to 1. That is, a is equal to 1 minus 2 by 3. That is, a is equal to how much here? A is equal to 3 minus 2 by 3, that is 1 by 3. Therefore, a is equal to how much? 1 by 3. Okay. From, if you are substituting s is equal to 1, from that case we got b is equal to 3, and equating the coefficients of s and s square. From that case we got c is equal to minus 1 by 3 and a is equal to 1 by 3. Okay. Now we know that unknown values of a, b, c. Okay, now substitute that unknown values of a, b, c in the above equation. After that, apply Laplace transform on both sides. Okay, therefore here a is equal to, therefore a is equal to 1 by 3 and b is equal to 3 and c is equal to minus 1 by 3. Now substitute all values in the above equation. What is the above equation? That is 4s plus 5 is equal to s minus 1 whole square into s plus 2 is equal to a by s minus 1 plus b by s minus 1 whole square plus 3 by s plus 2. Then if substituting here, that is 1 by 3 into s minus 1 plus b as 3 by s minus 1 whole square and c as minus 1 by 3 into s plus 2. Okay, this is equal to 4s plus 5 is equal to s minus 1 whole square into s plus 2. S minus 1 whole square into s plus 2. Therefore, apply both sides Laplace inverse. That is Laplace inverse of 4s plus 5 by s minus 1 whole square into s plus 2. That is equal to Laplace inverse of 1 by 3 into s minus 1 plus 3 by s minus 1 whole square minus 1 by 3 into s plus 2. That is equal to here 1 by 3 I'm taking outside and remaining 1 by 3 into Laplace inverse of 1 by s minus 1 plus 3 into Laplace inverse of 1 by s minus 1 whole square minus 1 by 3 into Laplace inverse of 1 by s plus 2. Okay, after that 1 by 3 into 1 by 3 into Laplace inverse of 1 by s minus a formula, that is e power t. 1 by 3 into e power t plus 3 into, once you observe Laplace inverse of 1 by s minus a whole square formula, there is no direct formula here. First apply for that first shifting theorem, that is e power t into Laplace inverse of 1 by s square. Okay, that is minus 1 by 3 into Laplace inverse of 1 by s plus 2, that is e power minus 8. Next step I'll write that is 1 by 3 into e power t plus 3 into e power t into Laplace inverse of 1 by s square means what? That is t minus 1 by 3 into Laplace inverse of s plus 2 means what? That is e power minus 2t. Okay, 1 by 3 into e power t plus 3 into e power t into t minus 1 by 3 into e power minus 2t. Okay, therefore here the final answer, that is Laplace inverse of 4s plus 5 by s minus 1 whole square into s plus 2 is equal to 1 by 3 into e power t plus 3 into e power t into t minus 1 by 3 into e power minus 2. If you know the concept of the partial fractions, easily you got the answer for the Laplace inverse of this type of function, that is 4s plus 5 by s minus 1 whole square into s plus 2. Okay, this is the concept of the partial fractions by using in Laplace transforms. Therefore, the final answer is this one. 1 by 3 into e power t plus 3t into e power t minus 1 by 3 into e power minus 2t. Okay, what we discussed today, using of partial fractions in Laplace transform. Okay, this is the topic for this. Okay, next questions we'll discuss in the next class. Okay, thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.